Hi everyone, I wanted to make a quick MATLAB tutorial for EECS 215. Hopefully some of you are familiar with it, but this should get you familiarized with some of the basic commands and functions. Okay, let's get started. This is what MATLAB looks like, hopefully when you open it for the first time. On the left, you have your current folder that you're working in. On top, it gives you the directory, the path of the folder that you're working in. On the right-hand side, you have a workspace where all your variables and the values will show up. This is the command window. So the command window is where you can run different commands in single commands, and the results will show up here when you run your files. So here is your MATLAB code, and this is where you write your entire code really. Okay, so I've divided this presentation into 5 parts. So part 1 will go over some of the basic commands, and we'll see what the rest of the parts are as we go through. Let's look at some of the basic commands just to get you warmed up. CLC, I would say, is the first command that I would look at. That clears the command window. So if I have, let's say, a equal to 1, I assign the value 1 to variable a, which you can also see here. I have one variable a and the value is 1. And if I want to clear everything that's in the command window, then I can just say CLC, and that'll clear the command window. Now, if I use the function clear, it's going to clear all the variables in this workspace. So if I say clear, here's all the variables. But let's say I have 2 variables, a equal to 1, b equal to 1, and I want to clear only one of them. Then I can just say clear a, and that'll just get rid of a, and I still have b left. Okay, so let's clear them and use CLC and go back to what's clean. We'll see what these two are, CLF and close all. So CLF is clear figures. It clears all the figures. Close all closes all the figures. We'll come across them later in some of the other parts. So the part 2 is solving a set of linear equations using linear algebra. Most of you have probably, all of you have done this in your first homework. So if I have a set of 4 linear equations, I can write them as a matrix and another vector. So I take all my constants to the right-hand side and all the variables with their coefficients on the left-hand side. And I write all the coefficients in terms of a matrix. So this is my matrix. And if I want to highlight something and just run this part, then I highlight it and I click on F9. So when I hit F9, that part gets executed. And now it assigns the value, the value of this matrix to the variable G. And now if I want to assign a vector, so one way to do it is to just say I equal to this vector. So now it has assigned it as a row vector, but I don't want it as a row vector. I want it as a column vector. So what I can do is I can put an apostrophe symbol at the end. So let's see what that does. This basically creates this converts from a column vector into a row vector. Really converts a matrix into its transpose. So let's say I put a column, an apostrophe at the end here, then I should get the transpose of what I had earlier, right? So let's compare the two. So if I remove it and I do it, then I get the transpose. So you can see here the rows have become the columns, right? Okay. Another way, obviously, to assign column vectors is just to put semicolons. Semicolons basically separate one row from another. So now I have a column vector. And to solve it, you can use this reverse slash sign. This uses, I think, the Gauss-Jordan elimination technique to solve the linear equations. Here's some other useful functions. G equal to rand 4. So this creates a 4 by 4 matrix of random numbers between 0 and 1. So let's run it. So I highlighted, I hit F9, and now you can see I have a 4 by 4 matrix of random numbers. I hit it again, gives me another set of random numbers. I do it again. Let's see, I keep doing it, I keep getting a different set. Okay, if I do it for, if I say ones of 4, then it gives me a 4 by 4 matrix of ones. If I say ones of 4 comma 1, then it gives me a 4 by 1 matrix, which is just a column vector of ones. And I multiply it with 2, so it gives me a column vector of 2s. I do that with 3 as well. And now if I want to take the element-wise product, which means I want to multiply this element with this and this element with that, then I need to use a dot between a dot and, a dot before I use the multiplication symbol. So dot multiplication multiplies them element-wise. So I get this. Let's see what happens if I don't use the dot. So then I should get an error, right? Because you can't multiply a column vector with another column vector matrix-wise. But if I convert one column vector to a row vector, then I can do it. And in this case, Since I'm multiplying a column by a row, I get a matrix. If I multiply a row by a column, then I should get a single number. And you can maybe think about why that happens. And if I want zeros instead of ones, I can do that as well using the zeros command. Okay, so that's part 2. Let's go on to part 3. So in part 3, I want to solve a set of linear equations using the symbolic solver. How I do that is shown here. So I assign symbols as w, x, y, z. So symbols are really just variables. And this is the command to do it. So you say sims for symbols, w, x, y, z. And then the 4 equations I have, I write them down in this format where the equal sign becomes a double equal sign, and I assign the equation to EQ1, which is, I guess, equation 1, using the single equal sign. So I do that for all 4 equations. So let me run the sims command, and then I run this. So then they all got assigned. And then to solve it, you use solve EQ1, EQ2. You write the first 4. If you have 3 equations, then the first 3 would be the first 3 equation values from here. And then the 4 values that you want to solve for. When you do this, you get a new structure A, which has all the solutions. And if I want to access an individual solution, let me show you how to do that. I say a.w. So that gives me the value of w that it has solved for. So let's say I want to assign this to some other w. I say w1 maybe, equal to a.w. So it makes w1 equal to the solution. But if I don't want it in a fraction and I want it in decimal, I can use this double function, which basically converts it into a double precision floating point value. I can do that for all 4 variables. And then I have all my solutions, which I had also using the same using a different technique earlier. It's the same answer. So this is how you solve it using the symbolic solver. So let's move on. The part 4, I guess, would be sort of long. This is where I talk about how you can plot stuff in MATLAB. This is very useful. In fact, for all my research, I use MATLAB for all the plots. You can do a lot of nice things in MATLAB with plots. So let's see how you do that. So if I have a data file, a dat file, I can read it using the read matrix command. I think you will have done this in homework 1. So let me run this. Okay, now since I have so many variables, I don't need all of them. So let me actually just clear all of them. And then also clear the command window. And then I run these 2 commands. I hit F9 and they get run. So these are some nice things you can try out. Size of data basically gives you the size of the matrix that's in this data. So here you can see it. It's 2000 by 2. So that's 2000 rows and 2 columns. And if I say length, let's say I say length, it just gives me the first dimension. So if I have a vector and I say length of that vector, it just gives me the length of the vector, the dimension of the vector. Okay. So figure 1, it creates a figure. So let's do that. Let me separate these 2 things. Okay. So it creates a figure, and then we need to fill this. So you can use the scatter plot to plot data. Instead of using a line that connects everything, you can use discrete points. So the x-axis is the first variable you enter, and then you put a comma, and then you enter the second variable. So what I'm doing here with this is, let me clarify that. So I have data. If I hit enter, then it gives me all the values, right? So I have 2 rows. So the first row, the first column, I have 2 columns and 2000 rows or 2001 rows. So the first column is the x-axis and the second column is the y-axis. So how do I access that? So if I say data of 1, 1, that gives me the first element, which is in the first row and the first column. If I say data of 2, 1, this is the second row and the first column. But if I want all elements in the first row from 1 to, let's say, 100, so I say 1 colon 100. So that gives me all the first 100, or let's say the first 10 elements from the first 10 rows. It gives me the first column element, right? And if I want all of them, I can just use a single colon, and that'll give me everything. But if I want, let's say from 1, or let's say from 100 till the end, I can just say end, and it's going to give me that as well. I guess you can't see it because it's very long, but maybe I can do this. 21997. Okay, so you can see these are the last 5 elements, right? So that's what's done here. This is basically taking all elements from the first column. All elements, yeah, from the first column. And this is taking all elements from the second column. And then I'm using dot as the, I guess, the indicator in the plot. So if I run this, let's see what happens. So it creates a dot for every single position. And the x-axis is this and the y-axis is this. Okay. So then when I say hold on, it holds on to this plot so that I can plot something else onto this. If I don't say hold on, so let me do that. I say clear, and what I said earlier, clear figure, CLF. So that clears the figure. Let me actually also close. So I say close all, we close the figure. So let's run this figure again. And then let's separate the two. Okay. Clear command window. And then I scatter, and then I don't say hold on, and I say, oh, I need to read the data again. Okay, now if I don't click on hold on and I do this, it's just going to erase the previous plot, but I don't want that. So I say, I plot this, I say hold on, and I plot the next one. So now this plots a line from the other data file. So in this again, we use the function plot. This just says that I want it as a dashed line, and this is the color. And I say the line width is 2, so it makes the line a bit thicker. Let's say I say line width is 5, and then you can see it makes it much thicker. Okay, and then if I say grid on, it creates a grid of all the x-axis and y-axis values. Okay, so the next label just labels the x-axis, and y labels the y-axis. Make sure you always have your units in brackets. And then if you want to add a title for the whole plot, you can say title, and that'll add it here. The title automatically is bold. And then the legend, basically, if you have 2 different plots or 2 different data sets in one plot, it'll separate them and it'll label them. So if I say legend, then it says, okay, the value data, which I've mentioned here, which was plotted first, is the first one, and it labels fit to the second one, to the second plot. So if I change this to, let's say, plot 1, and then I say legend, then it'll say, okay, the first value that I plotted is labeled as plot 1, and the second value I plotted was labeled as fit. And you can increase the font size to 25. Okay. So let's see some more plotting functions that you can use. Instead of using DAT files, you can also use CSV files, which I've done here. So these 2 files I've taken from some of the work that I've done before. They're just random files, I guess. So let's say clear, and then CLC, CLF. And then I say, okay, figure 2. I don't want figure 1 anymore. So let me close that. Close all. And now I say, okay, I want figure 2. So then I separate them, and then I read these 2 data files. Make sure you're in these files are in the working directory. If they are not, you can use something called add path. Maybe you can look that up. So say help add path, and that'll show you what you can do if you don't have these data files in the working directory. You can maybe read this and see how to use it, but anyway, so this is the syntax that you can use. Okay, so let's do that. So I read these 2, and then subplot is actually quite a useful command. So within one figure, if you want to have multiple plots into different sections, then you can use this command. So let's say I say subplot 2, 1, 1. So what does that do? So this actually says that I want a subplot division of 2 by 1. So which means I want 2 rows and 1 column. And the last one specifies which of those you are currently using. So let me use an example maybe to make that clear. So instead, if I say 2, 2, 1, that makes 4 squares. So 1 here, 1 here, 1 here, and 1 here. And this is the first element. This is the second element. This would be the third, and this would be the fourth. So now if I say subplot 2 comma 2 comma 3, that gives me the third element. If I say subplot 2 comma 2 comma 4, that's this one. And if I say subplot 2 comma 2 comma 2, that gives me this. Okay. So I say, okay, subplot, and then I want to plot the same thing as I did earlier, data 1 and data 2 that I read here. And I can specify the line width of the line, and I can also specify the color this way. There's a different way of specifying color, but B is for blue. So let's do that. So now I have my blue plot showing up, the x-axis here and the y-axis here. Okay, so if I want to plot the second plot in subplot 2, then I highlight this. Let's say I want subplot 2, and I plot the second data here. So here I've used a different style of color. This is basically an RGB from format. So it says this is red, green, and blue. So if I make R1, it gives me red. If I do R1 and G1, and then I plot this, and gives me yellow because red and green gives yellow, I guess. And then if I want to make this maybe, I don't know, 0, and this as 0.7. And then I run this, it gives me a kind of darker red because it's going towards black. 0, 0, 0 would be black. Okay. So then I can use xlim and ylim to set the limits of the plot. So if I run this, it sets the y limit from -10 to 22 and the x limit from -60 to 60. And then again, I do the same x label, y label, grid, and title. So now let's say I want to increase the size of these numbers. So then I can use these commands. So GCF font size, that increases the font size. And if I say grid alpha 1, that makes the transparency of the grid lines less, I guess, and becomes darker. And I can also set the grid line style to be colons, not colons, I guess, dashed lines. So this is the way I like to do my plots, is using this, but you can also use other functions. You can look this up. And then let's say I want more ticks. So I don't want -60, -40. I want everything between as well, or some things between as well. Then I can say from -60 to 60 with a spacing of 10. I want all my x-axis values to show up. So that'll do that. And y-ticks does it for the y-axis. So this way you can make really nice plots. But one thing you can notice here is that everything only got applied to plot 2. And if I want to apply them to plot 1, then I need to go back to, I need to activate the subplot 1 again. And to do that, I need to run this. So now I'm in subplot 1, and then I again run all of this. Right, so all of that gets done for this. And then if I want to put a title for both the subplots, then I can use SG title, and that'll give me a title for both subplots. I can set the font size and the font weight as well. Okay. Here are some other commands you can look at. Axis tight, for example, makes both the y-axis and x-axis hug the plot. So you can see, and it also gives me all the values. So it fits the entire thing together. Axis square makes the plot square. Axis equal scales them according to how many values you're plotting in each of the axes. And axis normal goes back to normal. So that's about it. You can use these to plot really nice things. Let me just show you in full screen how it looks. This is how it looks. So let's close and then go back to where we were. Okay. So in the last part, I want to show you quickly how to plot piecewise functions. I think some of you have used this, or most of you have used this in homework 1, but this should help you for future homeworks as well. Okay. Let me actually go full screen. So one way to do it is to use this piecewise function. And to use this piecewise function, you need to define symbols this way. So let me run this and see what happens. So when I run this, I have now 3 symbols, I, Q, and T, where I and Q are functions of T, which you can see here. So both of them are sim functions and T is the sim. Okay. So now I say Q of T is the piecewise function from, actually, this is basically the problem that you have in the text. Let me open that up. Anyway, so this is the problem from the text. So let's try and see how we can plot something like this. So I have sims I of t and q of t, and I say, okay, q of t, which is this one, it is, the value is 2 for t less than 4. And then from t from 4 to 8, the value is 2 plus half t minus 4, which is this part. and then above t equal to 8, the value is this exponential function. And that's what this does. It provides a function like this, and it's pretty straightforward. For the other piecewise, you can do the same thing. From 0 to 4, you assign 0, and then from 4 to 8, you assign a half, and then from 8 onwards, you can assign another exponential function. So once you define these two functions in terms of t, then I can define a new range t1, and then I evaluate these two functions in that range. So I say, okay, let me do the symbols. I'm just going to close this. Okay, and then I assign a new range. Hopefully you know how to assign this range. This goes from 0 to 35, and the value in the middle is the step size. So then I say, okay, subplot 1 in figure 1. So I go to subplot 1, and then I say I want to plot t1 as the x-axis and the value of q evaluated in this range as the y-axis, because q is now a function of t, and I'm replacing that t with this range t1. So, and you get this kind of a plot. So I turn on the grades, I turn on the labels, and then I also do subplot 2. So with this, I do plot grid label as well. And this is what you get. So this is what you've done, hopefully, for your first homework. In the future, you'll actually need to use something called the Heaviside function, which can be very useful. So let me quickly go over what it is and how to use it in MATLAB. So let's clear the plots. And let's say I have t going from -10 to 20. And now I define this function Heaviside of t. We'll see what that is as q1. So let's plot it. So this is what it looks like. The Heaviside function is the step function. The value is 0 from -infinity to 0, and the value is 1 from 0 to infinity. The value at 0 is not well defined, but so MATLAB basically defines it as 0 at 0. The value is at 0 to be 0. You can change that. You can ask MATLAB to define the value at 0 to be a half or even 1, because it's really undefined in this region, or at 0, not in this region. And you don't really need to know how to do that, but if you want to know, you can look it up on Google. Anyway, so that's what the Heaviside function looks like, and that's what we plotted here. But let's say I want to reverse the Heaviside function. So I want it to be 1 below 0, and I want it to be 0 above 0. So then I can use that. I can use something like this. So let me actually remove this 8. So if I do negative t, then I would get that. Right? So now it's the blue one. And now I want to shift this to the right, let's say, by a value 8. So then I put in 8 here, and then that shifts it to the right by 8. So let me maybe clear this and do it again. These. So now you can see the first part is the Heaviside function from this way, and the second part is the blue one. Okay, but now let's say I don't want a Heaviside function, I just want a step function that is 1 for a given range and 0 everywhere else. So then you can notice if you multiply these two functions, then everywhere else it becomes 0, because either of them is 0, either one of them is 0. And in this region where both of them are 1, over there the plot doesn't go to 0. That's what I've done here. I've multiplied the two. So let's plot that. Maybe it's easier if I clear the rest and then plot it. Okay, so I get a step function. And now you can use this to plot piecewise functions. So basically you take a function and then you multiply it with a step like this. And that will give you the function value only between this range, right? So maybe we can quickly see how that is done. So in this range, if I want to plot the exponential function, then I multiply this value, which I've written here, with the exponential function, right? And that's what you get here. This is what we had before. So in this range, now we have an exponential curve. And you can use that, you can combine it, you can add two Heaviside functions. So then in one range, you would get this, and another, you can add to that in a different range some other function, and you can create piecewise functions like that. So let me see what we can do here is, so here what I've done is the last part of the plot you saw earlier, which was from here. Let me pull this up. Okay. So this part from 8 to infinity, the value is 4. So that's what I've done here. Let me get back that plot. Okay. So you can see from 8 to infinity, I have a value of 4 and then goes down as an exponential. And I've used the Heaviside function to do that. Another way to use the Heaviside function is to define a function in terms of a variable. So when I say q equal to, let's say, q equal to at of t sine dt. So let me clear everything, CLF, clear and CLC. So let's run this. So now I have q as a function of t, and the value of this function is sine t. The reason I use sine dt instead of sine t is because sine dt uses arguments in terms of degrees, whereas sine t uses arguments in terms of radians. So if I say sine of pi, that gives me a value that's not exactly 0. It should be 0 because we know that sine pi is 0, but it's giving me something that's very small and not 0. Whereas if I say sine d of 0, I get exactly 0. And that's why I prefer sine d over sine, because it's more accurate. Because the reason it doesn't give you exactly 0 is because the value of pi needs to have infinite number of decimal places to be exactly correct. Whereas MATLAB can only store pi up to a certain value. So it gives you an approximate result. Whereas when you use this function, it gives you an exact result. Anyway, but that's beside the point. So if you use sine d of t, and I say, okay, t varies from 0 degrees to 720 degrees, and then I evaluate this function q in this range, like we did earlier, and then I assign that to a different value. So now I get, so now q sine is, let me open this up. Okay, so now q was a function, whereas q sine is actually a vector, right? Because it's already evaluated the function. And now I want to plot t1 versus q sine, and I can do that using what we've seen earlier. So let me plot it. So you can see it's a nice sine function. And you can use something similar for Heaviside function as well. And that's what I've done here. So I define Heaviside of t minus 8, where t is a variable now. Instead, earlier, we defined t for a given range and then use the Heaviside function. And then you can use a different range. And in that range, you can evaluate this function. The reason I do it this way as well is because, for example, in some cases, this value of t you need to extract from, let's say, a data set or a CSV file. So this would be, let's say, the first column in a CSV file, and you want to evaluate a function at the first column. So you cannot really write this down like this. You need to define it as a function of t and then get a range from the data file and then use that range and evaluate this Heaviside function using maybe this line. Hopefully that makes sense. Okay, so I do that. I evaluate this Heaviside function in this range using this equation, and then we can plot it. And you see it here. There is some slight difference here. For example, here, the curve is not exactly straight up. That's because when you define Heaviside function like this, it's defined as a function of a variable and not a function of a range. So it's a little bit different, but for this course, it shouldn't matter. So let's say I do what I did earlier using this method, and then I get the same plot. And again, you can see that it doesn't exactly go up to 4, stops short of 4, but don't worry too much about why that is. And that concludes the presentation on MATLAB. Let me quickly show you how to save files maybe. So if I want to save this entire code and all the outputs when the code isn't, so if I want to run the entire code and not a single section, so if I want to run the entire thing, then I can hit run here. But if I only want to run a single section, then I click enter. I mean, I click on that section and I click control enter, as I said earlier. Another way to run the entire code is to press F5. You can also do that. So let's say I want to save my code, all the results from the code, and I want to save all the plots that the code generates. Then I can use the publish option. So I go into publish, and then I click this and I say edit publishing options. I want it in PDF format, and you can change the path also where it gets published. And then I hit publish. So it's going to go through my whole code. It's going to run the whole thing, and then it will generate the results. So we'll have to wait for that, I guess. Okay. So let me show you what the result looks like. So it's created a table of contents based on the different sections that I have. And then for each section, it gives a nice heading and then gives me the code. So for this section, for example, this was the code that I had. And I also have the results here. So all the results that get printed. Right, and then I have part 3, same thing, all the results are printed. So part 4 had some plots, so it also prints the results that show up in a command window, and it also it gives the plots, so that's quite nice here as well. And yeah, that's about it. So you can submit maybe this file with your homeworks. And you can, if you want to edit some stuff, you can go to doc, make it a doc file or a Word file, or you can even use LaTeX, and you can edit your file. You can make it a PPT if you like. So that's pretty much the end of it. Another maybe useful function that you can use is the disp function. So instead of without suppressing, one way to like print something is without suppressing it, but you can also use the display function. So if I say disp print, or if I say, I don't know, disp hello, so that just prints hello. And you can use this disp command to do many things. So that's something useful to remember. And if you want to convert, let's say, one variable from one format to another, there are many ways to do that as well. You can look that up on Google. Hopefully this gives you a decent introduction for all you need. Of course, this cannot cover everything that MATLAB offers. And for that, you'll have to go to Google, or you can even type help here and look at the different commands. And when you need something, you can always look it up. But this should give you some introduction to get started at least, because hopefully that this is enough really to get started. Okay, so that's the end of it. Thank you. One nice cool feature of MATLAB maybe is to type y into the command window, and then it gives you a story. So you can just keep doing that and tell you some funny stories, I guess. I don't know. Maybe that's cool. Okay. Let me stop sharing and stop recording. Anyway, good luck for the rest of the semester.